Script Lesson 4, Conditional Statements, if, elif, else, making decisions in a program. Hello everyone. Welcome to the fourth lesson on Python Programming Basics. In previous lessons, we learned how to work with data, strings and numbers, and how to check their properties. For example, whether a string is a number or if it consists only of letters. We even saw how such checks return true or false. Today, we will learn how to use these true and false values to enable our program to make decisions and perform different actions based on conditions. In this lesson, we will master conditional statements, if, elif, and else. This is the foundation for creating intelligent programs that adapt to user input or changing data. Topic 1. What are conditional statements and why are they needed? Imagine you want to write a program that greets the user differently, depending on the time of day, or checks a password. This requires conditions. Conditional statements allow a program to check a certain condition. If the condition is true, i.e. true, then one block of code is executed. If it's false, false, then another block of code might be executed, or nothing might be executed at all. If, checks the first condition. Elif, elseif, checks the next condition if the previous if or elif were false. Else, executes if all preceding if and elif were false. It's important to remember about indentation in Python. The code that should be executed when a condition is met must be indented, usually 4 spaces or 1 tab. Topic 2, Comparison operators and logical operators. Before we start writing conditions, let's recall what operators we will use for comparison. Equal to, checks if 2 values are equal. Equals, not equal to, checks if 2 values are not equal. Greater than. Less than. Equals, greater than or equal to. Equals, less than or equal to. There are also logical operators that allow you to combine multiple conditions, and both conditions must be true. Or, at least one condition must be true. Not, inverts the condition, turns true into false and false into true. Topic 3, Error handling with try except, brief introduction. Sometimes, a user might enter data that the program doesn't expect. For example, entering text instead of a number. To prevent the program from crashing and throwing an error, we can use the try except construct, try. In this block, we place the code that might cause an error. Except, if an error, an exception, occurs in the try block, the code in the except block is executed. This allows us to catch the error and gracefully handle it, for instance, by displaying a clear message to the user, instead of the program simply terminating. In our examples, we will use try except for more robust handling of user input. Topic 4, Practical examples with if, elif, else, and while true for interactivity. Now, we will apply everything we've learned and create 10 interactive programs. Each example will run in an infinite while true loop, allowing you to input data multiple times and experiment. To exit a loop, you will need to type exit, or simply stop the script execution, for example, by pressing Ctrl+C in the terminal. Python. Start of Lesson 4, Mastering if elif else to 100%, 10 examples. This lesson focuses on solidifying your understanding of conditional statements, if, elif, short for elseif, and else. These constructs are fundamental for controlling the flow of your program, allowing it to make decisions based on different conditions. We will explore 10 diverse, short examples to illustrate their practical use. Each example runs in an infinite loop, while true, to allow for multiple inputs. And continuous experimentation. To exit an example, type exit. For some examples, the datetime module will be needed, but we will not explain its import in detail yet, focusing on if-else. Import datetime. Example 1, Determining number type, integer/decimal. Exits the current while true loop. Check if the string contains a dot. The dot count method returns the number of occurrences of the dot character. If there's a dot in the string and if after removing one dot the string consists of digits, then it's likely a decimal number. If the string consists only of digits, it's an integer. Check for a negative number, integer or decimal. If it starts with a minus and the remaining part, after minus and, possibly, one dot, consists of digits. If none of the above conditions are met. If float or int could not convert the string, e.g., 1.2.3. Example 2, checking for even or odd number, using modulo. Demonstrates using the modulo operator, %, to check divisibility. Convert input to an integer. The %, operator returns the remainder of a division. If the remainder of dividing the number by 2 is 0, the number is even. Otherwise, if the remainder is not 0, the number is odd. Example 3, determining mealtime, breakfast, lunch, or dinner. The program determines which mealtime it is based on the entered hour. If the hour is between 6, inclusive, and 11, exclusive. Else if the hour is between 11, inclusive, and 17, exclusive. Else if the hour is between 17, inclusive, and 23, inclusive. Else if the hour is between 0, inclusive, and 6, exclusive. In this case, if we reached this point, and the hour was in the 0 to 23 range, but it didn't fall into any of the meal conditions, it means this should not happen, as all hours from 0 to 23 are now covered. Therefore, this else would only be reached if not, 0 equals hour less than or equal to 23. Missed an invalid input, which is unlikely with the new check. Nevertheless, it can be kept for safety or removed if coverage is certain. I would recommend keeping it empty or removing it, as the first check handles everything. But for demonstration that it's on the correct indentation level, we keep it. However, with the first check, this else will effectively never be reached. For numbers 0 to 23. Please note, this else in the current logic will effectively not trigger for numbers 0 to 23, because all these ranges are now covered. It can be removed. Example 4, checking if a character is a vowel or consonant. The program determines if the entered character is one of the vowels. Check that exactly one character is entered and it is an alphabet letter. Using English vowels for simplicity. If the character is in the list of vowels. Otherwise, it's a consonant. If not a single character or not a letter. Example 5, Body Mass Index, BMI, Category Determination. The program calculates BMI and classifies it into categories: underweight, normal, overweight, obesity. Check for valid input values. Weight and height must be positive. Continue to the next loop iteration. BMI calculation, weight divided by height squared. Example 6, determining day category by time, morning, day, evening, night. Uses the current time to determine the day category. Get the current hour. If the hour is between 5, inclusive, and 12, exclusive. Else if the hour is between 12, inclusive, and 17, exclusive. Else if the hour is between 17, inclusive, and 22, exclusive. In all other cases, after 2200 hours until 5 o'clock. Example 7, Basic, Guess the Number, Game. The program generates a random number and asks the user to guess it. Import the random module here, directly before its use. This demonstrates that modules can be imported where they are needed, although they are typically imported at the beginning of the file. Generate a random integer between 1 and 10. Convert user's guess to an integer. If the user's guess is lower than the secret number. Else if the user's guess is higher than the secret number. If the user's guess is equal to the secret number. To make it continue, you can choose not to break here, or add an option to play again. For this example, we break. Exit the game loop after a correct guess. Example 8, checking if a string is empty or not. Simple example to demonstrate checking for an empty string. Checks if the length of the string is 0. Example 9, Password Strength Checker, simple. Checks if password length is adequate and if it contains numbers. Assume strong, default to true, then set to false if a condition isn't met. Check if any character in the password is a digit. Any char is digit, for char in password underscore input, returns true if at least one character is a digit. No else here, as messages are printed within the if/elif conditions if weak. The strong password message is only printed if all specific weak conditions are not met. Example 10, checking if a user's chosen animal is a mammal, bird, or fish. Categorizes animals based on simple classification. Conclusion. Great job! Today, we mastered a powerful programming tool, conditional statements. If, elif, and else. Now your program can think and make decisions, reacting to various conditions and entered data. We learned how to use if to check conditions, how to apply elif to check additional conditions, how to use else to execute code when none of the conditions were met, how to combine conditions using logical operators and, or, not, how to use try except for safer input handling, how to work with the infinite while true loop for continuous testing. This knowledge opens up huge possibilities for creating more complex and interactive programs. Remember the importance of indentation in Python. It's not just style, but part of the syntax that defines which code belongs to which condition. Practice, change the conditions, come up with your own tasks. For example, try to write a program that determines whether the number entered by the user is even or odd. In the next lesson, we will delve into loops. This will allow us to repeat actions multiple times, which will further expand the capabilities of your programs. Thank you for your attention. See you in the next lesson.